Last time, when we talked about elements of cluster design, we covered aspects of the head node because that's where your initial user experience happens, and you can do so many things there to make your users' lives more pleasant. This week, though, we're going to be talking about queue design, and with me, as usual, is Matt Vaughn. Hey, Matt.
Good morning.
So, for the sake of getting us all oriented, Matt, let's define what we mean by a queue.
It's just a virtual bin of jobs that users submit batch jobs to in a cluster. Then what happens is that the scheduler looks at the availability of all of the resources and the estimated resources that are required by the job, and it makes decisions about what instances and when where those jobs can run. Every cluster has at least one queue, but usually more than one because they help with the management of a finite resource, in this case, your HPC cluster.
But that finite resource could actually also be a customer's budget too. So
that's right.
It seems to me that, queues, despite a really cool t-shirt that we made for reInvent a few years ago, queues really are still relevant in the cloud, right?
That's right. Even if your cluster can expand and contract to fit the amount of work there is to do, we still need a framework for telling the scheduler what work needs to be done. And also a lot of HPC workloads incorporate interactions with the queue. Here in the PCUI and the wizard interface, to get started, there's 3 top-level settings that we have to decide on. The first is whether the cluster is going to be configured for memory-based scheduling or memory-aware scheduling. The second is what is our scale down time for the cluster. And the third is what is the queue update strategy. And these apply to every single queue on the cluster. Memory-based scheduling means that users have to specify how much memory a job needs. And this lets the scheduler treat memory, not just the CPUs, as a schedulable resource. This lets Slurm co-place jobs on an instance without worrying that one job will take up all the memory and impact the other jobs.
Okay, so scale down time is the amount of time after all of the jobs have finished running before ParallelCluster says, hey, these nodes are no longer in use and I need to reap them and send them back to EC2 so that, well, just to begin with, the customer isn't still paying for them when they're doing nothing. But that scale down time is there so that you just don't end up with massive amounts of churn. A bunch of jobs finish, nodes disappear, but 2 seconds later, a new bunch of jobs arrive at the front of the queue and get scheduled, and then we have to spin up more nodes again, and yada, yada, yada. So that 10-minute buffer, now, of course, you want to tweak that to your own taste.
Yeah, 10 minutes is a good baseline, that's why it's our default. You might want it to be shorter if you really want to be sure that you don't pay for any instance time except what your compute runs on. But you might want it to be longer if it takes time to acquire instances and you prefer not to wait.
Now let's talk about the queue update policy.
Yeah, this describes what needs to happen to the jobs that are running in your queues when the administrator, in this case probably you, wants to update a configuration in the queue or anything that would affect running jobs. So the default behavior is compute fleet stop. And that means that you have to stop the whole compute fleet, basically pause all execution on the cluster in order to update a queue setting. And that's a very conservative approach. You can also choose drain or terminate. With drain, the running jobs keep going to completion, but no new jobs are accepted into the queues that are affected by the change until that update is finished. Now, if there are queues that you're updating that aren't affected at all, they will just keep running happily. But if you are changing one specific queue, it'll essentially go into drain, update, then return to service. So with terminate, running jobs are actively terminated. Then the queue gets updated, then it's returned to service. So personally, I like to use drain on an active cluster. That way I can happily change my queue settings without disrupting any ongoing work, but then I also don't have to pause the whole cluster.
Yep. And your users will love you for taking an approach like
queues. By default, there's already one queue that's ready to go. If you want to add more queues, you just keep adding queues. I think you can add up to 10 queues, which ought to be enough for anyone, just like 64K of memory, 140K of memory.
If you need more than 10 queues, you've already made your site and your life too complicated.
Let's just start with a real easy name like simple. So this is how that queue is going to present in Slurm commands like sbatch, sinfo. So keep it short, keep it memorable, minimize the amount of typing you and your users are going to think. Now you pick a subnet. Unless you've got a great reason, that subnet should be in the same AZ or availability zone as the head node.
Oh, yeah. So now with the purchase type, Matt, it looks like you can choose on demand or spot, right?
Correct. So if you're okay with your jobs getting terminated occasionally and you want to save up to 70% of the on-demand price, you can run on EC2 Spot. ParallelCluster makes that really easy. The adjacent setting, which is allocation strategy. And this is something that's relatively new. It's been covered in a blog. It's been covered in some documentation, but it's really worth hearing about. Essentially, when you're running in Spot, you've got two options. You can choose lowest price, or you can choose capacity optimized. So this basically answers the question: when you're requesting Spot instances, do you want to launch from pools where the price is the absolute lowest, or do you want to launch from pools where there's best instance capacity? Both cases are going to help save you money, but capacity optimized will reduce the chance that your instances are going to get reclaimed while they're supporting a job because there's more capacity.
It's worth saying that when we say on demand here, we mean on demand or perhaps reserved instances. Reserved instances really are kind of a general form or a specific form of on demand. If you happen to have a bunch of RIs that you've bought, or you're on a savings plan, then all of this will contribute to that, and you'll get billed at the RI rate. Okay, cool. So it looks like we've arrived at actually setting up the compute resources, and this is where we get to do cool things like, pick the right CPU architecture for our types of jobs, and maybe GPU to CPU ratios or memory to core ratios. How do we do that?
Yeah, so we're going to set up compute resources. So this is something that is largely hidden to most users of a Slurm cluster, but Slurm supports this kind of thing automatically. A compute resource is just a logical pool of instances that can serve as execution hosts for the Slurm queue. And all your compute resources don't have to be the same. So you can have just one compute resource, or you can have many. ParallelCluster uses the order where you've defined your compute resources to determine priority.
So, Matt, to me, what this really means is that you're going to have these sort of stack-ranked sets of compute resources inside, to be able to fulfill the needs of a queue. For example, I could choose Ice Lake processors as my first compute resource. And I could have multiple instance types in there that are all Ice Lake processors with EFA adapters on them. And that'd be like, all of the 6th generation, M6i, C6i, etc. And then I could stagger back down through the list. And if I felt like it, I could say that it would be totally okay to go all the way back down to Sandy Bridge, in like Gen 4, because I happen to know that my job is okay with that kind of thing. Is that correct?
That is absolutely right. So you can stagger CPU architectures or CPU generation. You could also have a similar arrangement with the spot market.
For today's purposes, let's stick with one compute resource because I'm a simple boy.
You can configure static nodes and dynamic nodes. So the total number of instances available to the compute resource is the sum of these two numbers. Let's say a cluster has a baseline level of work that it always needs to be ready to do. Maybe there's hourly jobs that run a forecast model. So you can keep a handful of instances warm by setting them as static nodes, and they handle that baseline. But sometimes a lot of extra work comes in, maybe a special request to do another forecast or a data processing job. With dynamic nodes, ParallelCluster can bring up additional nodes to handle that work, then spin it back down to just the static base level when that work's complete. And the static nodes, of course, keep hanging around. So you are going to notice in this user interface that you can pick more than one. We're going to get to that later. For now, we're going to pick just one. And I'm actually not going to use C5N large. Okay, so let's choose something powerful, like a C6i. So I'm going to pick this. Note it's 128 vCPUs, 256 gigs of memory. Notice that UZFA became available.
You always want to turn that on. If that box is there for you to check, just check it. It costs you nothing.
Yep. And sometimes it's turned off because one of your instance types wasn't a full physical node. So you just want to be sure that it's on if you're selecting. If it's available, definitely have it on.
And associated with that, you should always click on the other box a little further up, use placement group.
Yes.
For all of the same reasons. EFA is a much happier thing when it's running in a placement group. A placement group it's like a hint to the EC2 scheduler that you're running HPC jobs, and you would really love it if all of the nodes that it allocates to you are close to each other in the data center in terms of the data center network.
That's right, because the speed of light is not just a good idea, it's the law. Notice that there's also an option to disable multi-threading. So if you select this, it disables hyperthreading on the vCPUs in this resource. Here's why you would do this. Some codes have better performance without hyperthreading turned on. The only time that we can really effectively do this is when we bring up the nodes. So you have to do it at a compute resource level. Whether you turn it on or off is dependent on your workloads.
You know, a lot of HPC folks just have an instinctive desire to turn off multi-threading. Mm-hmm. Perfectly legitimate thing to do.
All right, so we've got advanced options down here. Again, this is at the level of the compute resource. This is very similar to head nodes. You can add security groups. You can choose to use a custom AMI. You can run scripts when the node starts. You can run a script when the node's configured. You can set the size of the ephemeral storage allocated to each node, set the volume type, encrypt it. You can also set specific IM policies for this compute resource /queue.
That might actually be a case where you've got a particular need for those compute resources in this queue to be able to access a certain data set that's in an S3 bucket that the rest of the cluster can't access.
That's right.
That'd be a perfectly good example. There's a lot of so all of this stuff is at the level of the compute resource, not the queue. Like this is really quite granular setting. So if you really need to, you can customize a lot of stuff here. Let me just let's just do this. And so Matt, obviously we've now defined one queue containing a compute resource, and we know that a queue can contain multiple compute resources. But if we wanted to just add more queues at this point, we'd just keep clicking the add queue button, and it'd just give us another card that we'd fill out, right?
Exactly, just like I've done here. Add queue, remove queue.
Perfect. And likewise, down inside the queue, the add compute resources, you just keep adding and removing compute resources until you had exactly what you needed to suit. I guess there's another thing that we want to consider, and in fact, you alluded to it a minute ago when you were talking about choosing the right subnets and choosing the availability zones for running for putting your queue into. There's a bunch of detail that's worth considering. If somebody does want to build a cross AZ queue architecture, or more to the point, just a cross AZ parallel cluster, there's some things you should consider when it comes to how your storage interacts with it and how your queues are designed. And in fact, we're going to go into those in a different video. Thanks, Matt.
Of course. Bye-bye.
If you learned something from this talk, then please consider giving us a like and subscribing to the channel so you can find out when more videos like this are available. And if there's an area you'd like to see us go deeper into, don't hesitate to reach out and let us know. See you next time.